Hello and welcome to the DataSunrise functionality demonstration. This demo includes three simple scenarios: database firewall, dynamic data masking, and database activity monitoring. Here is the website created for the demo. It displays content of two PostgreSQL tables. It includes names, addresses, emails, credit card numbers, and passwords. I'll use this website to show you the features of our product. First, I need to define what database DataSunrise should protect, so I enter the configuration section of the web UI. Here you can see a list of all existing database profiles. I've created a profile for my PostgreSQL database. So let's take a look at its settings. The settings include the profile's logical name, database type, connection details, and a list of existing proxies or sniffers. To use all DataSunrise functions, I need to deploy it as a proxy between the database server and client application server. In this particular case, between the web server and the PostgreSQL database. I've created a proxy for the database and configured the website to connect to the database through the DataSunrise proxy. Having created a proxy, I can start using DataSunrise features. Let's start with a database firewall. First, let's assume that it is required to prevent the database user attempts to change the customer's names, that is, the first and last names. To do this, I need to create a data security rule, a data security policy which prohibits editing of the first name and the last name columns. I entered the security section of the web UI, and you can see the list of existing rules here. It's empty now, so I need to create a new rule. To do that, we click Add Rule. In the main section, I need to give a name to our security rule. Let it be a rule that blocks any data modification. Also, in the main section, I specify a database I want protected. It's my PostgreSQL database. In the action section, I select an action the rule performs when triggered. It is the block action by default, so I don't need to change anything if I want to block prohibited queries. Also, I'm checking the log event in storage box to have all security events logged and registered. In the schedule subsection, you can set schedules to enable and disable the current rule at a predefined time. In the notification subsection, you can configure notifications of concerned parties in case of rule triggering. Depending on how you've configured it, DataSunrise notifies subscribers via email or instant messengers. In the filter sessions, I need to define which database user shouldn't be able to change information in the database. It's the user called DataSunrise. And now I need to define what kind of queries should be treated as prohibited. And I go to the filter statement section. I configure the filters to treat queries aimed at data modification as prohibited. Then I specify the database columns to be protected. These are the first and last name columns. I can save the settings now, and my security rule becomes active. Now let's try to change a customer's name. Let's do it to the first customer from my database. As you can see, my attempt to modify the protected columns is blocked by the firewall. It says that the query is blocked. However, since I've configured the firewall to protect only certain columns, I'm still able to modify other columns. Now let's proceed to dynamic data masking. First, let's assume that it is required to obfuscate the credit card numbers, passwords, and emails. To do this, I need to create 3 masking rules for card, password, and email columns respectively. I enter the data masking section of the web UI. Here is a list of the existing rules I've set up in advance. Let's take a look at their settings. In general, the settings are similar to data security rules. I've specified the database in the main section. Since data masking is the default action, I don't need to check the skip checkbox in the action section to mask the data. Also, I decide to log all masking events and check log event in storage. In the filter sessions, I've defined the database user for which I want to obfuscate the database output. In the next subsection, I specified the column to be masked. It's the credit card column. Also, I've selected a masking method to apply. It is the credit card number masking algorithm. Now I enable and save the rule to make it active. I've created a similar rule for passwords. I specified the database, the user, and chose to mask the password column. I've selected another masking method, fixed string. It replaces the column values with this predefined string. Along with built-in masking methods I used for previous rules, you can create your own custom functions for masking. I've created such a function for emails. Since my PostgreSQL tables are linked by the email column, this column is the primary key, and I need to specify the columns from both tables. From the drop-down list, I've selected the function call masking method and specified the function to call. Now let's check the table. As you can see, the values in the card column were masked. The password values were masked, and emails were replaced with some random values. Now we can proceed to data auditing. Let's assume that I need to monitor all attempts to access my table. To configure monitoring, I enter the data audit section of the web UI. Here is the audit rule I've created. Its settings are almost similar to other types of rules. I've configured the filter statement section to audit all queries directed to both of my PostgreSQL tables. This rule was running all the time I was showing other features. So let's check the auditing results. I enter the transactional trail subsection, and here you can see a list of auditing events. Let's check the details of one of the events. To do that, you need to click the event ID. Here you can see the basic section providing detailed information about the audit event. Session information includes the database username, name of the client application used to send the query, the application's hostname, and session duration. Below, you can see the query itself. DataSunrise audits not only queries, but also query results, which you can see here. By default, audit data is saved into an integrated SQLite database. You can also use an external database such as PostgreSQL, MySQL, MariaDB, Microsoft SQL Server, or Redshift to store these data. Auditing data can be exported to an external SIEM application with syslog messages. Thank you for watching this demo and for your interest in DataSunrise.